Assalamualaikum and salam UiTM di hatiku to our beloved lecturer, Madam Faridah Zulkipli, as our lecturer for code QMT342. So today we are from F4CS1115B Group 3 will present the queuing theory project that we have done, which is our observation of queuing system is at 7-Eleven shop.
First, I would like to introduce my group members. First, Nur Afiqah binti Mohd Fawzi. Second, me, Mohd Taufiq Hidayat bin Roslee. And third, Nur Aleea binti Mohamad Hashim. Let me start first with the introduction. The location of our observation is 7-Eleven Seri Iskandar Perak. The operating time is from 6 a.m. until 12 a.m. We observe for 1 hour from 8 p.m. until 9 p.m. Number of server or counter at 7E Seri Iskandar is 1. Actually, it's 2. But during the pandemic, they just use 1 to keep the social distance between staff.
Next slide, I will present about the characteristic of queuing system. There are 3 characteristics of queuing system. First is arrival, second is waiting line, and third is service facility. For arrival characteristic, at 7-Eleven Seri Iskandar Perak, the size of calling population is infinite, or we call as unlimited. It means that the arrival rate is not affected by the number of customers in the system. In our study, 7-Eleven is viewed as an open system where the customer come from outside the system and leave the system after finishing the work. From our observation, all the customers that came to this 7-Eleven, they want to buy something such as buy a top-up or food, and they also want to pay the bill in this 7-Eleven. Then, they will queue at the counter to pay, and after being served, they will leave the shop. Next, the pattern of arrivals at the system, which is our lambda, is 28 customers per hour. And the behavior of the arrival is the patient customer, where all the customer willing to wait in the queue until they are being served.
Next characteristic is waiting line characteristics. The length of the line is infinite or unlimited. The number of customers waiting in line does not significantly affect the rate at which the population generates new customers. Last but not least, the queue discipline or the waiting line priority rule use first in, first out. First in, first out is generally considered fair, yet it is biased against customers requiring short service of time.
Next slide is the third characteristic of queuing system, which is a service facility. So, the configuration of the service system is a single channel system, which means it have one counter that open, or we call as one server only. Then, this 7-Eleven is single phase system where the customer receive their services from only one station and then they exit the system. For the pattern of the service time, our mu, which is the exponential distribution, is equal to 30 customers per hour at 7-Eleven Seri Iskandar Perak.
Next, 2.4 Basic Queuing System Configurations. We want to figure out the type of queuing system used for 7-Eleven. Before that, Service systems are classified in terms of number of channels or server and the number of phases or service stops. For our project, which we observe or survey 7-Eleven, the basic queuing system configuration is a single channel system which one server is quite common. To elaborate, the customer will arrive and make some purchases. After that, they will queue to make payment while the cashier will serve the customer. As you can see, for the figure 1, there are arrivals, then they will queue to make a payment while they've been served by the service facility, which is the cashier in the service system. After that, there will exist the 7-Eleven. This is the picture of the situation in 7E. You can see that the customer queue to make payment and there only one counter serve the customer. For the result, the number of arrival is 28 customers per hour, which is our lambda, follows Poisson distribution. And the service rate is 30 customers per hour, which is our mu, follows exponential distribution. Since the number of server is 1, we will use formula for single channel queuing model. Firstly, we will start calculate for L, which is the average number of customer in the system. We get 14 customers per hour. For LQ, which is the average number of customer in the queue, we get 13.07 customers per hour. For W, which is the average time a customer spend in the system or the total time in queue and counter, we get 0.5 per hour or 30 minutes. For WQ, which is the average time a customer spends waiting in the queue, we get 0.47 per hour or 28.2 minutes. For P, which is the utilization factor for the system, that is the probability that the service facility is being used, we get 0.93.
Last but not least, the conclusion. Comment on the number of server provided and the customer waiting time. Is the number of server provided adequate? Yes, because the customer are served at a faster rate than they arrive. Are the customers happy with the waiting time? Happy, because the customer been served on time. What we have learned while doing this project. While we're doing this project, we learned that if average service rate mu is more than average arrival rate lambda, so that customers are served at a faster rate than they arrive, the service will be fast. If lambda is more than mu, then the queue will get larger and larger indefinitely. On the other hand, the service will be slow. That's all from us. Thank you.